Hello, everyone. Looking at starting Unit 3 here, starting to look at how data is collected and represented, and more specifically, kind of how it's done in a fair way. Okay, so you got a little cartoon here in front of you with a two monkeys or apes, and then there's a somebody recording some data in the background, and it looks like the adult monkey is saying, "Now eat that banana." The nice statistician is watching us. So good joke to start off the chapter with. This chapter doesn't have a ton of like your traditional math in it. It's a lot of definitions and understanding things that way and based off that. Um, so again, we're going to start looking at collecting data, statistics, and interpreting that, and doing so in a fair way. So there's three things that make a good statistic. The wording of the question or the situation. We don't want any bias in how something is worded. Um, and so the way that you word a question needs to be as fair as possible. The people that you surveyed need to be fair. We need to have good representation in a survey. We can't just be focusing on one group because then that also can skew the results. And then we obviously have to figure out, well, what are we even trying to measure, and how are we going to measure that? And so those three things make a good statistic. But encompassing all of that is then how the statistic is interpreted and is translated to other people. One thing that you'll hear throughout this chapter and throughout future chapters is that two people can look at the same statistic and interpret it in a different way. Data can say whatever you want it to say. And so just keep that in mind, and just in life in general, you have to be careful when you hear statistics on the news or on, even if you think it's a credible source. If we just talk about Fox News and CNN, they will and they do take the same exact information and they skew it for their audience. Okay, and that's not to pick on one over the other. They both do it. And so you just have to be careful. Even if you think it's a good source, you have to be careful with what the bias might be behind that information. Okay. So statistics are made up of individuals and variables. Individuals are the people that you are trying to measure, or the objects that are being described in the data. Might not be people. Could be animals. Could be trees. Could be anything you might be trying to take data on. And then the variable is the characteristic or characteristics that you are trying to measure. And so those are the things that we're trying to collect. The data that we're trying to collect are the different variables. And so if we just look at a quick example, who are the individuals, who are the variables of this scenario? So it looks like we've got four people, four employees of Cyberstat Corporation. And of course, the actual people in this case, we'll go with Cedillo, Tanya Chambers, Amanda Childers, and Huabang Chen would be the four individuals here. Okay, those are the four people that are being measured, and the variables in this case would be the different, again, categories or characteristics that we are measuring them by. And so in this case, we are measuring them by their job type, age, gender, race, and salary. Okay, and so those would be the 5 different variables that we have in this example. Okay, so again, the individuals are the actual people that you are measuring, and then the variables are what you are measuring from those people. Speaking of variables, or speaking specifically about variables, there are two different types of variables, categorical versus quantitative. Now, you need to be careful in assuming that quantitative variables are always number related, because that is not always the case. A way to think of the difference between a categorical versus a quantitative is a quantitative variable might be a variable that you would do some sort of arithmetic with. So, oftentimes you hear on the news or with statistics that the average of whatever was this. The average salary for males versus females is this versus that. So salary is a quantitative variable because that would be something that would make sense to find the average salary or the median salary of a company or whatever the specific scenario might be. On the other hand, if we look at some examples of categorical, finding the average employee number or the average zip code or the average jersey number, that's not something that we typically do. Specifically thinking of sports, I've never heard of a stat where somebody says, "Oh, in the NBA, the average points scored for a person that wears jersey number 12 is this." Like that just doesn't make sense. Your jersey number has no implication on how many points you're going to score. And so any quantitative doesn't just mean if it's a number, it's a quantitative variable. But if it makes sense that we might perform some sort of arithmetic with that, like finding the average, that's what makes it quantitative. Other examples of categorical are anything that, again, characteristics. So age, gender, race would be categorical. Hair color, eye color, left hand, right hand. Those are all different types of categorical variables. And then again, quantitative, salary, points, hits, hourly rate, etc. Height and weight would be quantitative because again, it might be meaningful to find the average height or the average weight of something. So those are the two different types of variables. So let's look at just labeling each one. Okay. Again, if it's not a number, then it's pretty easy to say that it's categorical. If it is a number, that's where we have to think a little bit more. And so, something like gender, that's a categorical variable. Okay. Something like height, again, you have to think to yourself, might it make sense? Would there be a scenario where we would want to find that the average height is meaningful in a survey? And that's definitely something that could be helpful in finding the average or the median of. Shoe size, that one's a little bit tricky. There might be specific cases where the average shoe size might mean something. In most cases, I would think not. But technically, it might make sense to calculate the average shoe size and come away with some piece of information there. Okay. The number of siblings that you have. Again, if we're talking like economic type of data, it might be helpful to find, if you average this many siblings, your family might be in this or that type of economic standing. So that would be quantitative. Favorite pizza, again, that doesn't even involve numbers, so categorical. Number of contacts stored in your cell phone, can probably call categorical. You could find the average number of contacts that somebody has, but what is that going to help with us? Types of music you prefer, categorical. Dominant hand, we already said that one is categorical. In a typical school night, how much time do you spend doing all these things? That's quantitative. Okay, that's in fact data that I think we collected at Mount Westonka here when we were looking at doing the late start times. So that was definitely helpful data that we found the average of or the median of for most students. And then what month were you born? Again, I know we assign numbers to months, but again, we don't. We might say people born in January have a higher tendency of this or that, but again, it's not a numerical thing. That's a categorical quality there. Okay. Again, if it's not a number, then it's pretty easy to say it's categorical. If it is a number, that's where you have to think of, would it be helpful to ever find the average of this? Okay. And so let's put all this information together. Individuals, variables, categorical versus quantitative. Okay. So looking at one last data set here, in Super Bowl, let's see, that would be 37. The Tampa Bay Buccaneers defeated the Oakland Raiders. Here is a portion of the team's roster. Okay, so here are the individuals. We got Brad Johnson, former Viking great, Warren Sapp, Martin Gramatica. If you've never seen, if you don't know who Martin Gramatica is, which I would assume you don't because he retired a long time ago, he would celebrate the easiest field goals as if he just won the Super Bowl all the time. So if you want to see something kind of funny, just go and Google his name on YouTube and watch it, just a video of him celebrating. He actually got hurt one time. He twisted his ankle or something like that and actually missed a bunch of time because during a celebration he hurt himself. And he would do that if it was a 20-yard field goal or a 50-yard field goal. Didn't matter. So kind of entertaining. Anyway, Tom Tupa, another individual in this data set. Looking at the different variables, okay? Again, the data itself is one thing, but just the characteristics that you're measuring are the different variables. So number, position, height, weight, birth date, experience, and then the college they went to. Okay. Again, it wouldn't make sense to average out a jersey number. All right, that doesn't help us really do anything. So that's categorical. Anything that's not a number is also categorical. Height and weight, quantitative. Birth date, categorical. Experience can be quantitative. It could be helpful to know the average number of years that your team has on its roster. And then college is definitely categorical. Okay. So that's kind of just an introduction into your statistics, just identifying who you're measuring and how you're measuring them. Okay. And so when you are collecting data, there are two general subgroups that we have. Observational studies versus experiments. Think of the difference of these as observational studies is more of like questionnaires. So you're asking questions of people, or you're quite literally just observing them. Okay, where an experiment, and I'll just go right to the definition here, deliberately imposes some treatment on individuals. So oftentimes you might have, and we'll talk about an example like this in a little bit, but you might be testing out a new medication. And in order to test out that medication, you need to run an experiment. You need to find individuals that are willing to take this medication. But what's interesting about those types of experiments, and all medication goes through this, even Advil, way back in the day when it was first created, had to get approved by the FDA, you have to run an experiment on it. But what's interesting is that you might get 20 people to agree to this experiment, but you're only going to give 10 people the actual pill. The other 10 are going to get what's called a placebo pill. It's basically a sugar pill. It doesn't have any of the active ingredients in it, but you don't know that you're taking the placebo. So 20 people sign up, 10 get the actual medicine, 10 get no medicine, but nobody knows other than the people running the experiment what they're actually taking. And so just if you didn't know that is how medicine is either approved or not approved by the FDA. But anyway, when you are collecting data, there's two general ways to do it, and throughout this whole class, we'll kind of dive more into different types of observational studies and experiments. But those are the two types of ways that you can collect information. So again, we have other types of observational studies. We have sample surveys, where you measure characteristics of some group of individuals by studying only some of its members. That's very common, right? If we wanted to take a survey at Mount Westonka High School, it's probably not realistic to get a sample from every single person here. So I might pick 200 kids and get surveys from them. And so the population in that case would be Mount Westonka High School. That's the entire group. But the sample is just the part of the population which we draw conclusions from. So again, in the example that I just kind of went through, I picked 200 people. Those 200 kids are the sample, and I am going to make a conclusion about Mount Westonka as a whole based on what those 200 people say. And then there's a census. In the United States, we attempt to do a census every 10 years. In fact, it is a census year right now. And so your parents will be bombarded with mail from the Census Bureau pleading and begging over and over again that they fill it out, because they are literally trying to reach every single person in the United States so that they get an accurate measure of how many people live here. Again, obviously that doesn't happen. It's technically not impossible, but it's about as close to impossible as you can get. But that is called a census when you try to get every single person in a population. So if I tried to get every single person at Mount Osanka to answer a certain question, that would be a census. And again, it's a census here. So, and you'll even see they hire people to walk through neighborhoods so that if you haven't taken the census, not only do they send you mail and probably emails, but they have people walk and knock on your door and ask you to remind you to take the census. And again, it's nearly an impossible task to get everyone. And so in 1990, it was estimated that about 1.6% of the population was actually missed, was not counted. And then in 2000, it was estimated that 1.3 million was overcounted, and so that would be a mistake on this bureau's part where maybe they collected data from the same family twice, type of thing. Again, not perfect, almost impossible for it to be perfect, but we try. Okay, and that's a census. So again, a census is getting everybody. A sample is just taking a part of a population and drawing conclusions about the entire population. And again, that is definitely the most common way to do things. But because of that, right, if I take 200, there's roughly 1,000 kids at Mount Osanka. If I take only 200 of them, then I can draw a conclusion, but it's going to have what we call a margin of error. It might not exactly represent the population as a whole. And so a margin of error formula was developed at some point that will help you approximate the population. Okay? And this formula is actually pretty simple. It is 1 over the square root of n, and because I'm taking a square root, there's a plus or minus there, where n is the sample size of that population. Okay? So, if I look at this example below, it says if 25 people were surveyed and 65% oppose a new law, then the approximate results of the population would be what? And so if 25 people were surveyed, this is the sample in this case. So again, that is n. So I'd take plus or minus 1 over the square root of 25, which is 1 over 5, plus or minus, which is going to translate to plus or minus 20% of the population. And so the approximate results that we could actually say are 45 to 85%, which isn't a very good range. Okay, typically you want your range. I mean, obviously, the closer it is to 0, a range of 0, the better. But 20% is way too big. We want to be less than 10 at worst, if not even less than 5 when you calculate a margin of error. Okay, but just to reiterate, what you do is you take that margin of error, in this case plus or minus 20%, and from the sample statistic, 65%, you add and subtract 20 from that. And so that's where we got the 45 to 85%. Okay. Now, one thing that this example doesn't tell us is what is the population? For example, if we surveyed 25 people and the population was only 30, well, then maybe that's actually a pretty good sample. If we surveyed 25 people, but the population was 1,000, again, now we're talking about something where we probably should have surveyed more people. Again, this is where you can't always just trust what statistics tell you. We have some things in place that can help us understand that data might not be exactly perfect, but you can't always just assume that the person telling you the data is being completely forthcoming about it. Looking at another example, a survey of a random sample of adults in a state reports that 44% approve of the governor's performance. If 2,000 people were surveyed, then what is the margin of error? Okay, so again, here is our sample. All right, that is our n. And so I've got 1 over plus or minus the square root of 2,000. All right, and the square root, 1 over square root of 2,000, ends up being about, we'll call it 2.2%. So comparatively, this is a way better margin of error because my the approximate range for my population is 44 minus 2.2, 44 plus 2.2, which would then equal 41.8 to 46.2% of people approve of the government's performance. Okay? And again, even this margin of error isn't going to be super exact. If we were to actually take a census and get results from the entire population, we might find that the population isn't in this range. Okay? But again, it's just a way to try and be a little bit more transparent with your data and to say that there's a range of values that the population might be between. Okay, statistics and data can never be perfect unless you truly get a census. And again, it is almost impossible to get a census. And so data and statistics, it is almost impossible for it to be 100% accurate, although the margin of error allows us to have a certain level of confidence at its accuracy. Okay. So just some different places, and I'll actually go to Gallup real quick. Gallup is the definitely the most popular one that takes random polls of different surveys. And so if I, man, they've changed their website a little bit here. Let's see if I can just find, like, do you need an account to access things now? Who we are now. Okay, well, they used to have, they used to, let's go click on some education stuff, see if they have it in there. Wow, they've really changed. They really locked things up. Anyway, what the Gallup poll does is they collect a sample of about 3,000 people on various topics, and then just produce data based off that. They right in their polls, they will tell you what the margin of error is, and so that you again take that data and consider it with the margin of error. Again, Bureau of Labor Statistics, they take different types of surveys in terms of households, and they try to get 50,000 a month and just collect different data, again, economic type stuff. And then the Nielsen TV ratings. You can choose to participate in this, where you allow Nielsen Company to track what you watch. And so that's how, when you hear like so many people watch the Super Bowl, that's what they do. They take a sample of the people that they are tracking and then make a general statement about the whole population. Okay. So if we start putting all of this together from what we've been talking about in this first set of notes from Chapter 3. It says about 3,000 adults were interviewed by the General Society Survey about their opinion on poverty, abortion, and war. So what is the sample? The sample, in this case, is the 3,000 people. Okay. The population, all we know is that the 3,000 people were all 18 plus. Okay. We don't know, we don't even know if this is in the United States or not. So the population that we can only assume that this talks about are adults, worldwide, I guess, theoretically, that are 18 plus. Okay, we can't interview adults and then make a generalization that this is also what kids think. Those are two different types of people. Okay, so this sample, based on what we know, only represents the population that is 18 plus. Okay, the individuals of the sample are the 3,000 people that were interviewed. Okay, and the variables are the opinion on poverty, abortion, and war. Okay, those were the things being measured, is the opinions on poverty, abortion, and war. Okay, so again, just putting this all together. The sample is who was interviewed. Those were also the individuals. What did it represent? From what we know, it represented just people that are 18 plus. It only represented adults. And what were they measuring? The variables that they were measuring was their opinion on poverty, abortion, and war. Okay, so that is kind of a summary of observational studies. One way to collect data. Again, it's very much either literally being observed, or more often than not, it's kind of like a questionnaire-based survey. Okay. Our next method that we're going to talk about is looking at experiments. All right, and here's another funny, super funny cartoon for you. Looks like we got a little baby here running an experiment. This baby has thrown all of their toys out of their crib, and according to the experiment, 0 out of 10 toys will bounce back into the crib. Okay, so there you go. There's a good belly laugh for you. So let's just identify. Experiments are pretty cut and dry. Again, it is imposing a treatment. Okay, there's not as much detail that goes into an experiment in terms of the sample versus the population versus this and that. We are imposing a treatment, and we are seeing if that treatment works or not. So it's looking at this example. It says there may be a gender gap in political party preference, with women more likely than men to prefer Democratic candidates. A political scientist randomly asked registered voters, women and men, whether they voted Democratic or Republican. Okay, is this an observation or an experiment? Again, they were just asking a question. They did not impose any sort of treatment, so this is an observational study. And the variables that they measured are just Democrat or Republican. 885 people of similar variables, age, occupation, etc., were divided into 2 groups to determine if vitamin C can prevent the common cold. One group unknowingly took 4 grams of vitamin C per day. The other group unknowingly received a placebo pill with no vitamin C in it. Again, a placebo pill is basically a sugar pill. And so of these 885 people, nobody other than the scientists running the experiment knew whether they were actually taking vitamin C or not. They could have been taking vitamin C, or they could have been taking literally just 4 grams of sugar every day. Okay? But there was a treatment imposed here. They were taking a treatment. They were taking vitamin C to see if it could prevent the common cold. So this is an experimental survey. Right? So again, in general, if I were to summarize this as easy as possible, an observational study is some sort of questionnaire. I think I spelled that wrong. I think it's 1 N and 2 R's, isn't it? There we go. Some sort of questionnaire. An experiment is when we impose a treatment. Okay? Kind of focusing on the word treatment there. Anytime we are actually, taking something, that is an experiment. Okay? And then to summarize data, we have something we call this statistical solving problem process. Okay? So we first need to start by asking a question of interest. All right? Again, this needs to be as unbiased as possible. Okay? So for example, do people remember more when they hear or see? If you were to ask a similar question and you worded it like, don't you hear better, or don't you remember more when you hear things? Well, now you've skewed that question. You've skewed it towards just hearing something rather than saying hearing or seeing. Okay? Then we need to produce the data. You need to figure out, would it be best to perform an experiment or an observational study? Okay? Then we need to analyze the data. That's what this chapter is a lot about, is analyzing, producing, but then also analyzing data with graphs, numerical summaries. And then interpret results. We need to interpret those. If possible, answer the question of interest. Sometimes you go through a whole process and you realize the data was inconclusive. So you spent all that time and energy and realize, we weren't able to conclude anything. But you need to be fair and say that. Okay? Remember, data can say whatever you want, but it is always expected that we are being fair when we interpret and analyze data. Okay? So that's it for 3.1 to 3.6. A lot of different learning targets going on. It's just, mainly looking at samples versus populations, individuals versus variables, and experiments versus the observational studies. Okay?